This is a lesson for Chapter 4, Section 4, Graphing Linear Equations in Slope-Intercept Form, Day 1. So let's take a look at the first problem we'll end up seeing here. And it says that we're going to graph the equations and interpret the y-intercept and slope. So we have to figure out what the y-intercept is. So we have two different intercepts when we're talking about a graph or a line in which it crosses the y-axis and the x-axis. So the x-intercept of a line is where that line crosses that x-axis, so this point right here. So that's when y is 0, it says. And that's what you'll see, because you see the ordered pair for this is whatever the value of the intercept is, comma 0, because we're not going up or down. Where the y-intercept is where it crosses the y-axis. And so notice that you don't go left or right, so that's why the x value is 0. And then we have a slope-intercept form, and this helps us graph the line, and it's in this form, y equals mx plus b, where b is the y-intercept, the slope is what changes x each time, that is the coefficient of x, and then we have our output of y and our input of x. So let's take a look at it. This is in that slope-intercept form, so notice the form goes y equals mx plus b. And so what we need to do is identify what the y-intercept and the slope are. So the y-intercept, and I'm going to use the variable b to represent that, is equal to negative 2. So it's this component right here. So y is negative 2, where the slope is represented with the variable m, and the slope of my line is negative 4. And so I'm going to treat that negative 4 as negative 4 over 1. And the reason I'm doing that is because this will tell me what to do in the y direction. And this tells me to go down 4 spaces, where the 1 in the denominator tells me to go right 1 space. And so I'm going to go down 2 spaces for that y-intercept. Again, that's my y-intercept there. And then I'll follow that slope. And again, the slope said to go down 4 spaces and then right 1 space. But I'm kind of running out of room there, and I actually put that point off the graph, but I see this is 3, and one more would be about this far, and then over 1. Well, I can also go the other direction. So this is what I did. I went down 4, right 1, but that's the same thing as going up 4, left 1. So I can go up 1, 2, 3, 4, left 1. You see I end up on that line. If I did it again, I'd go off the graph once more, but I can kind of get an idea about where that point goes. So you can see these points form a line, and that's what the line would generally look like. So put some arrows at the end signifying that it goes on forever, and we've got our y-intercept at this point, and our slope matches. See, down 4 spaces and then over 1 space. Let's take a look at the next one. It says y equals 3x minus 7. So minus 7, I have a hard time fitting that on this graph, so I'm going to change that number. Let's go ahead and change that to maybe a minus 5. It'll be a little bit easier for me to fit it on the graph. So I'll go ahead and change that. And we start down here at negative 5. That's the y-intercept. So my y-intercept equals negative 5 once more. But this time the slope is going to be 3, because that's this number right here. So this is my slope, and my y-intercept is right here. And so I'll treat that 3 as 3 over 1. So I'm starting at negative 5 here, and I'm going to go up 3 spaces, 1, 2, 3, and then over 1 to the right. And I can do that a couple more times as well. So we go ahead and draw a line between those points. And our line this time is an increasing line, so it's got a positive slope. Notice that when it's positive, it ends up going uphill from left to right. When it's negative, it goes downhill from left to right. So let's take a look at some other types of problems. So we're going to be doing the same thing here, graphing the equation, but then also interpreting the y-intercept and the slope. What makes these a little bit more challenging is that we have to get y by itself. Remember, our slope-intercept form goes this way, y equals mx plus b, where b is the y-intercept, m is the slope. What's different about this is y is not by itself. So I have to do an opposite operation to get y by itself. So I'm going to add 5 to both sides, and I get this. So now I've got y equals, and then 3 halves x plus 5. So now I know what my y-intercept is. My y-intercept is 5. My slope is 3 halves. So I'm going to start up 5 spaces on the graph and then use that slope. Now, typically the slope would tell me to go up and then right, but I'm running out of room. I can't go up and right with my graph. Now if I could, I would go up 3 spaces and then over 2, so it would be somewhere around this area here. So I know it's going to go down this way. So the other way I could go is down 3, left 2. See, the 2 negative signs would cancel, and again that tells me to end up going down 3 and then left 2. And you see, I would get in that region that I thought it would be, in this region over here, when I go down 3 spaces, 1, 2, 3, 2 to the left, down 3 spaces, and then 2 to the left. You see, I end up on that line where I thought it would be, and that would end up matching what I've got. And so, try drawing that a little straighter. So there it is, the line with arrows at the end signifying it goes on forever. Again, we've got our y-intercept up here at positive 5. That's this value right there. And the slope, and I can use the slope from this point here. You see how I go up 3 spaces, and then I go right 2. So that would get me on that line, up 3 and right 2. That represents the slope. Over here, same sort of thing. I have to add the 1 to all sides. And so when I do that, I now have y equals negative 2/3 x and then plus 1. So I'm starting with the y-intercept of positive 1. You're going to use the slope of negative 2/3. And so I go up 1 space, put the dot right there, and then use the slope. And the slope tells me to go down 2 and then right 3 spaces. And then if I run out of room that way, I can go the other way as well. So this again meant down 2 and then right 3. So I can go the other way. If I went 2 over negative 3, that tells me to go up 2 spaces, up 2, but then I'd have to go left 3. So up 2, left 3 puts me right there. And so once I have those, I've got a few points I could draw a line between. And so that's my line. So again, the y-intercept is the number that is added to the x term, where the slope is what gets multiplied by the x term. So in this next problem, it says the cost y in dollars of taking a taxi x miles is this equation right here. And so we're supposed to graph the equation. So typically, when I graph equations, I have a fraction as this term. But I could use the decimal form, or I could use the fraction form. I'm going to just go ahead and stick with the decimal form here. But I'm going to also show you that this is the same thing as saying y equals, now if I change this to a decimal, into the fraction form, it would be 2 1/2, which would end up changing to 5 halves. And then that would be 5 halves x plus 2. And so we'll talk about both instances. But before we do that, we have to label our graph. And so this x-axis represents the number of miles. So number of miles. And the y-axis represents cost. So this is in dollars here, and this represents the cost. And so we're going to go up by, let's go up by 1s in this case. So I'm going to call this point here 2, and this is 4, and this is 6 here, and this is 8. And so you can see in between there would be the 1s, and we'll just go by 1s here as well. So 2, 4, 6, and 8. So I'll just mark these a little bit more so they're a little clearer. And we'll go ahead and plot our points. So we start up at $2, and that's our y-intercept. Again, the y-intercept is 2, because that's what it says right here. And the slope we can either treat as 2.5 over 1, or I can treat that as 5 over 2, whichever is easier. So let's take a look at both of them, see what you like. So up 2 spaces, and up an extra half space would be here, and then over 1. And that's where that point would go. Or I could end up going up 5. So 5 would be double 2.5. So 5 is 1, 2, 3, 4, 5 over 2. You see, I end up on that line either way. And so just keeping it as a fraction makes it so we don't have to deal with the decimal component. We just have 2 integers to deal with. And so that's what our line looks like. So let's go ahead and draw a line between those. And now let's interpret what the slope is. So the y-intercept here, this value, which is our y-intercept, represents what the fare is, or what you're going to end up paying if you travel no miles. So at traveling 0 miles, you pay $2. So just to sit in the taxi without even moving, you're going to pay $2 no matter what. And so the slope, and let's go ahead and take a look at what a slope is. This is our slope. Our rise, so we rose 2.5 over 1. And so this was 2.5 rising and then over 1. So the slope is, we'll use that 2.5 over 1 this time, means you pay $2.50 every mile you travel. So initially, the y-intercept tells us our initial amount. We're going to pay $2 just for sitting in the cab, just for entering that door. But then, after we start moving, we're going to pay $2.50 every single mile. And so that would be the same thing as paying $5 every 2 miles. It's just another way of saying it. So those are the types of problems you'll see on the homework. Good luck.